On this video, we will be looking at conversions between mass and volume of one gas to volume of another gas. Now this is a bit of an overlap in that it is stoichiometry and it does require stoichiometry setups to solve the problem. However, we are dealing with volume, which constitutes gases, and therefore this would be both stoichiometry and gas law information. Let's begin with a mass volume problem. In a mass volume stoichiometry problem, we convert a given mass of chemical A to an unknown volume of chemical B. This is a three-step conversion problem, as we must first convert from given mass of chemical A to moles of chemical A. We will then do a mole-mole conversion from moles of chemical A to moles of chemical B. And finally, we will convert from moles of chemical B to liters of chemical B. Now this can be set up as one continuous problem, and it will be no longer or no more difficult to solve than a mass problem. Let's look at an example of a mass volume problem. How many liters of hydrogen are produced from the reaction of 0.165 grams of aluminum metal with dilute hydrochloric acid? Now notice that we do have our balanced chemical equation, which is necessary for all stoichiometry problems. And notice that we are given information about aluminum. This will be our chemical A, and our chemical B will be hydrogen. So to solve this problem, we must first convert from grams of aluminum to moles of aluminum, then use our coefficients to convert from moles of aluminum to moles of hydrogen, and then finally convert moles of hydrogen to liters. Now this is our new step that we are looking at. I do want you to notice that we are at STP. STP stands for standard temperature and pressure, and this right here will allow us to use a standard conversion that I will show you on the next slide. Well, let's look at the solution to this problem. Here we have that balanced chemical equation. Now notice that we have 0.165 grams of aluminum. This was stated in our problem. We have 1 mole of aluminum over the weight of aluminum from our periodic table, allowing us to cancel out of grams. We are using our coefficients from our chemical equation. Notice that we used the 2 for aluminum and we had the 3 for the hydrogen. That allows us to cancel out of moles of aluminum. We are now in moles of hydrogen. This is our new step. At STP, 1 mole equals 22.4 liters. Now let's write that down, and if you do not have this on your Fat Daddy, you would want to add that. So we have 1 mole of any chemical equals 22.4 liters, and this is at STP. Now this is a standard. Now that we have that, because our problem specifically said that we were at STP, we can use this conversion factor, 1 mole on bottom, 22.4 liters on top, moles cancels out, we do the math, and we get 0.205 liters of hydrogen gas. With volume-volume stoichiometry, we need to bring up the scientist Gay-Lussac. Now Gay-Lussac did quite a bit of research and experimentation with gases, and in addition to his gas law, he discovered that volumes of gas under very similar conditions can combine in whole number ratios. This is known as the law of combining volumes. So let's look at the reaction H2 plus Cl2 yields 2HCl. We can use our coefficients to determine our volumes of our gases. Let's say that our problem gives us 10 milliliters of hydrogen gas. It would react with 10 milliliters of chlorine gas to produce 20 milliliters of HCl. And we do this because we are using our coefficients. So the ratio of the volumes is a 1-1-2 ratio using those coefficients. With that said, let's look at a volume-volume problem. How many liters of oxygen reacts with 37.5 liters of sulfur dioxide in the production of sulfur trioxide gas? Notice that we have our balanced chemical equation. Now from this balanced equation, we have 1 mole of oxygen reacts with 2 moles of sulfur dioxide. So 1 liter of oxygen would react with 2 liters of sulfur dioxide. Now this is using those coefficients. So we can solve our problem using a liter-liter conversion, which is very similar to a mole-mole conversion. We take our 37.5 liters of sulfur dioxide. We use our coefficients to convert from liters of sulfur dioxide to liters of oxygen. We have 1 liter of oxygen, and we're using that coefficient, and we have 2 liters of sulfur dioxide using its coefficient. Liters of sulfur dioxide cancel out, and we would have 18.8 liters of O2. Well, let's add to that and say, how much sulfur trioxide could we make? Well, we would do a liter-liter conversion using sulfur dioxide, and we would convert to sulfur trioxide. So 37.5 liters of sulfur dioxide. Again, we will be using our coefficients, allowing us to cancel out of liters of sulfur dioxide, placing us in liters of sulfur trioxide, and our answer would be 37.5 liters of sulfur trioxide could be produced.